Hello there, and welcome to our morning lesson in which we are going to look at compound interest. Remember, in our last lesson we were looking at simple interest, and when we defined simple interest, we said it is the type of interest that is earned or paid on a loan or an investment, and it is basically calculated based on the principal amount invested or borrowed. So unlike in simple interest, where the interest is only calculated based on the principal amount, in compound interest is a bit different, such that as you move from one period to another, the principal amount tends to increase. We not only calculate the interest based on the principal amount, but also on the accrued interest. That is the difference between simple interest and compound interest. So as time goes by, you'll discover that the principal amount will tend to increase. Let us take, for example, we can start from the simple interest formula where we were saying that interest is basically equal to the product of the principal amount, the rate, and the number of periods. And let us say, for example, at the end of this operation, you end up getting an interest like X. So what I'm trying to say is that when it comes to compound interest, when we are through with the first period, this might be the first year or the first period, such that when we move on to the second year, the principal will have changed. When we are calculating the interest in the second year, the interest will be calculated from the new principal, and this new principal will be the old principal plus the interest that we obtained during the first period times the rate. The rate does not change, multiply by the period again. And you will realize that these periods are usually one. They are usually one. And if we were to calculate the compound interest in the third year, and we had obtained here the interest as Y, then it means that in the third year, our interest will be calculated from this principal that we had here, multiply by the rate, multiply by the period. Like that, as you move on from one period into the next one, or from one period to the preceding ones. So that is what is unique with a compound interest. This compound interest can also be calculated using the simple, the advanced or the improved simple interest formula, or we also have the compound interest formula. But first, let us define what we mean by the term compound interest. Compound interest. We have said that this is a type of interest that is paid or earned on a loan or investment. A type of interest that is paid or earned on a loan or an investment, which is calculated not only on the principal amount, but also on the accrued interest. I have said that this compound interest can be calculated in two ways. The first method of calculating compound interest is using the updated simple interest formula. That is method one. We also have a second method of using the compound interest formula. The compound interest formula. With these two methods, we are assured of getting the same results. There are two different methods, but they lead us at the same end results. So in this lesson, I want us to start by first using the updated simple interest formula. Because we are well conversant with this, we have used it in our previous lessons. Then we will move on and look at what do we mean by the compound interest formula, what are the components in the compound interest formula, and how do we apply the same formula. Using the updated simple interest formula. And to illustrate this, let us move on to examples. These examples will help us to understand this new concept. Our first example, we are tasked to calculate the compound interest on $100 compounded at 10% annually for 2 years. We are tasked to calculate the compound interest on $100 that is compounded annually at 10% for 2 years. Remember, we had learned in our previous lesson that before you handle such a question, it is good that you list down the terms that are given together with their values. We list the terms that we are given together with their values. When you look at the question, we are provided with the principal, which is $100. We are also provided with N, which denotes the number of periods, those are 2 years. We are also provided with the rate, which is at 10%, and this is the same as 10 out of 100. And we said that this rate, we can write it as a fraction or a decimal before we apply the same in the simple interest formula. The second thing we learned was that we write down the simple interest formula. We write down the simple interest formula, which was actually I, which is the interest, is equal to the product of the principal, the rate, and the number of periods. And lastly, we learned that we substitute in the values and evaluate. We substitute in the values and evaluate. This was what we learned about simple interest, but we want to update this simple interest formula every period as we move on, for us to be able to calculate the compound interest that will be accrued. So if we start by looking at the first year, so in the first year, we can call it year 1. The interest will be equal to the principal multiplied by the rate multiplied by the number of period, which is 1. And this is going to give us, our principal is 100 multiplied by the rate, which is 10 out of 100 multiplied by the period, which is 1. And this, when we cancel the zeros, we are going to get an interest to the tune of $10. That is in the first year. If we were calculating simple interest, we will stop at that. And in the second year, in which I'm going to call year 2, we have agreed that the principal will change such that our interest, we will have a new principal. Instead of having this 100, it will be 100 plus the interest that we have calculated in the first year. The principal will be 100 plus 10, because we are going to accrue some interest on the principal as well as some interest on the interest that was accrued in the first year or in the first period. So this will be this new principal multiplied by the rate, still remains the same, multiplied by this second year or this second period, and this is going to give us the sum of 110. This will be 110 as our new principal multiplied by the rate multiplied by 1. This will give us an interest to the tune of $11. So the interest in the second year, you will discover that this interest is more than the interest in the first year. Why are we getting that difference? Because in the second year, we are not only accruing interest on the principal amount, but also on the interest that was accrued in the first year. So at the end of the second year, the compound interest will be the sum of the interest in 2 years, and this we are saying will be the sum in the 2 years or 2 periods, and this will be $10 plus $11, giving us a sum of $21. This will be the compound interest. This will be the compound interest. Let us move on and look at a second example. Let's look at a second example. Consider $500 invested at 10% per annum. Compounded annually. We have a principal that is $500. We have the rate that is 10% per year. And the first part of this question is how much interest is earned in the first year. How much interest is earned in the first year? And as a norm, we are going to list down all the terms that we have been provided together with the values that we can extract from the question. Having done that, we are going to write down the simple interest formula, because that is what we are applying to be able to calculate the interest that will be earned in the first year. So we have been provided with the principal, which is $500. We are also provided with a rate that is 10%. We can write this as a fraction or a decimal, that is 10 out of 100. And we are told in the first year, that means our period will be 1. We go ahead and write down our simple interest formula, which is the product of the principal, the rate, and the period. We then substitute in the values that we have before we evaluate. The principal we are given is 500 multiplied by the rate multiplied by the period. And this, the zeros will cancel. This will give us an interest of $50. In the first year, the interest that will be accrued will be $50. Let us look at the second part of this question. What is the balance of the account once the first year's interest is added? What is the balance in the account once the interest of the first year is added? We want to know the balance, because after accruing an interest of $50, it was an investment. then we expect that the principal amount that was invested together with this accrued interest will be present in the account. So the account balance will be the sum of the principal investment plus the interest in the first year. And this is going to give us $500 plus our $50, which is the interest. And at the end of the first year, the balance in the account will be $550. This is as far as the second part of this question is concerned. Let us try and move on to the third part and see what we are required to do. The third one is how much interest is earned in the second year. How much interest is earned in the second year? Remember, in the first year we have earned an interest that investment of $500 have earned an interest of $50. So we move on and calculate the interest earned in the second year. How much interest is earned in the second year? And as we have observed in the first example, is that in the second year we are going to have a new principal. And this principal will not only include the initial principal invested, but also the interest that is accrued during the first year. So this amount of $550 will be our new principal during interest calculation in the second year. So we can go ahead and list the items that we have. The principal we have is a new principal of $550. The rates will remain, which is 10 out of 100, and the period is another year, and that is 1. That is the second year, but it is still 1 year. So we go ahead and write down our simple interest formula. We want to update it. This will be the principal plus the interest earned in the first year. We can call it interest 1, multiply by the rate that has not changed, multiply by the period. And this will give us the sum of principal plus the interest in the first year. We have it is here, and it is the one that we are using here. This is 550 multiply by 10 out of 100 multiply by 1. And if we calculate this and this one cancels, this and this, we are getting an interest in the second year of $55. Remember, in the first year we got the interest as $50, and as we move on to the second year we discover that the interest is also increasing. So if you have so many years, let us take for example 10 years, you'll discover that the interest accrued on the 10th year will be much more compared to the interest that was accrued in the first year. So this is the interest that is accrued in the second year. That is the interest that is accrued in the second year. The next question is, what is the balance in the account? What is the balance in the account at the end of the second year? What is the balance in the account at the end of the second year? That is the question that we need to answer. So you'll discover that in the first question we had the first principal, and this we can call it the second. And now we want to get the balance in the account. The balance in the account will be the sum. The balance in the account will be the sum of the principal in the second year and the interest accrued in the second year. In the second year. These two will give us the balance in the account. These two will give us the balance in the account. And if we go ahead and calculate them, this will be, remember the principal in the second year was $550 plus the interest accrued in the second year, which is $55. When we add this, we are going to get, this should be $605. This will be the new balance in the account at the end of the second year. So every year you discover that the amount accruing in the account increases. And that balance at the end of the second year that is found in the account is the one that is used as the principal during the next period or the next year. This is what we should have realized. There is something that we want to do that will tease our minds. We have this as the balance in the account at the end of the second year. The last bit of this question is, we are asked to use our calculator to work out $500 multiplied by 1.1 raised to power 2. We use our calculators to work out this. You can start by keying in 1.1, then you raise that to power 2, then you press the equal signs. After which, that answer should be multiplied by 500. And if you work out this, you will discover that this will give us 605. This will give us 605. This is just a hint of what we expect when we will be using the compound interest formula. Let us look at a third example. Let us look at a third example that is in form of a table. Copy and complete. The table below. Given that $400 is invested at 12% per year for 4 years. For 4 years. This is the table we are having. There we go. We have our table complete. In the first column, we have the time. In the second column, we have the amount, denoted by the letter A. We also have the interest in the third, denoted by the letter I. And in the last column, we have the new amount. The new amount. We have the new amount. Of course, here we have the first year. In this first row, we have the first year. And the amount in the first year is $400. How much interest are we going to get from this amount, given that we are going to use only the first year as the period? That is what we want to discover from this. So we are still using the simple interest formula, the updated simple interest formula to fill this table. So we go ahead and write down our simple interest formula, which is the interest being the product of the principal, the rate, and the period. And this interest, we have our principal as 400. The rate we are given is 12%, which is 12 out of 100 multiplied by 1. How much does it give us? Let us try to cancel it. This and this, this and this. So 4 times 12 will give us the interest. 4 times 12 times 1, which will be 48. So the interest that will be accrued in the first year will be $48. The interest that will be accrued in the first year will be $48. What will be the new amount in the account at the end of the first year? It will be the sum of this and this. And your guess is as good as mine. 400 plus $48, this will give us $448. That is the new amount that we will have in the account. During the second year, remember this is compound interest. During the second year, what will be the amount? The amount will be that bank balance at the end of the first year. This will be $448. $448. How much interest will this amount attract during the second year? We go back to our simple interest formula. And in this simple interest formula, we have a new principal. This is the column for principals that should be used to calculate the interest. This will be 448 multiplied by the rate still remains the same, which is 12 out of 100, 12% multiplied by 1. And when we do that, this will give us $53.76. This is the new interest that will be accrued in the second year. If we denote this as interest 1 or interest in the first year, this will be our interest in the second year. And this interest in the second year we are saying is $53.76. $1,276. What will be the new amount in the account at the end of the second year? Or what will be the bank balance at the end of the second year? The bank balance will be the sum of these two. Will be the sum of these two, and this will be $501.76. We are proceeding on well. I hope you can now help me to get the amount in this first column during the third year. What will be the amount? Just from the previous row, we said that this amount here will be the bank balance at the end of the second year. So this amount will be 501.76. How much will this amount attract in terms of interest in the third year? Because we are on the third year. We are still applying the simple interest formula. And this interest will be equal to the product of the principal, the rate, and the period. But our principal will be this new amount. Our principal is 501.76 multiplied by 12 out of 100 multiplied by 1. How much will that be? We can use our calculators to calculate that. Which is 501.76 times 0.12 times 1. This will give us 60.21. 60.21. This is the interest that will be accrued on this amount in the third year, and what will be the new amount at the end of the year will be the sum of this and this. And when we add, this will give us $561.97. $561.97. And the same procedure can be used to calculate all these variables in the fourth year. The same procedure should be applied to calculate these variables in the fourth year. This amount will be 561.97. How much will it attract as interest in the fourth year? This will be the interest in the fourth year, will be the product of the principal, which is 561.97 multiplied by the rate multiplied by the period. How much will that be? That will give us 67.44. This will be $67.44. And the new amount in the account will be the sum of 561.97 plus 67.44, and this will give us $629.41. I have just rounded that to the nearest dollar. So this will be the bank balance at the end of the fourth year. This will be the balance at the end of the fourth year. And a question might arise. You might be required to calculate the compound interest at the end of the fourth year. How do we get the compound interest at the end of the fourth year? Compound interest compound interest. This will be the difference between the amount at the end of the fourth year, the difference between the amount and the principal, the amount that was invested. This interest will be the difference between them, and this amount is 629.41 minus the principal that was invested. It was just $400, and this will give us an interest to the tune of $229.41. This is the compound interest that will be accrued over a period of 4 years. So a point to note is that as you move along, you will discover that these amounts will tend to change. The amounts will change to increase continually as you move from the first year, the second year, the third year, the fourth year. And if the question was having more periods, let us say for example 10 periods, the amounts will tend to increase continually up to the last year. I hope you have understood how to apply the simple interest formula in calculation of compound interest. It is not a one-step process. It is a continuous process, and every step will lead to the next one. So you need to exercise caution when you will be dealing with this particular simple interest formula to handle the compound interest questions. Before we move on to looking at how you can calculate the compound interest using the compound interest formula, it is good that we know how to convert rates and time periods, because those are the items that will come in handy when we'll be looking at the compound interest formula. So let us move on and look at that before we call it a day. We want to look at converting rates and time periods. Rates and time periods. These are denoted by small letter n. How do we convert these rates? If they're expressed in percentages, how do we convert them from percentages to fractions and to decimals? When we will be looking at the compound interest formula, you will discover that we only use the rates that have been expressed in decimal form. And in our previous lessons, we looked at how to convert percentages to fractions and to decimals. We will just revisit those particular concepts. Another thing that we need to know, apart from conversion of the rates, we also need to know how many periods do we have. Because when they say that compound interest is going to be compounded monthly in a year, it means that we have several periods within a year. Remember, a year has 12 months. So if they are going to compound the interest monthly, within a year we will have 12 periods. So it is also good that we know how to convert the periods given and to know the exact number of periods that we have before we feed the same information into our compound interest formula that we will learn. Let us use an example to look at how to convert this. In this example, we are told to calculate the number of periods and the rates of interest. Calculate the number of periods and the rates. The rates of interest offered per period for the following. Question A, 6% per annum over 4 years paid monthly. So there are two things we are supposed to calculate. We are supposed to calculate the rates, and we are also supposed to calculate the interest. Maybe we can start by calculating the periods. How many periods will we have? How many periods will we have? Remember, these rates are going to be compounded monthly. So the number of periods, small letter n, how many periods do we have in a year? If at all, 1 year has 12 months. It means we are going to have 12 periods within a year. But in this case, we are provided with a duration of 4 years. These are 4 years, and each year has 12 periods. So how many periods are we going to have? This will be 4 times 12, giving us 48 periods. That will give us 48 periods. Let us now look at the rates. We are told that the rates we are given are 6% per year. If we have the rates of 6% per year, what will be the rates per month? What will be our rates per month? Remember, we have 12 months, so we are going to divide this by 12 to get the rates per month. And to convert the same into decimals, remember conversion of numbers to decimal, you divide that number by 100. Like if you want to convert 2 to a decimal, 2% to a decimal, you basically divide this by 100. So this will be divided again by 100. And that is going to give us 0.005. Those are the monthly rates that we are going to have. Let us look at another example very fast. We have 18% per year over 3 years. Over 3 years, paid quarterly. Paid quarterly. What will be the periods? What will be the periods? This will be determined by the number of years we are given, which is 3, multiplied by, we are told that they are paid quarterly. How many quarters do we have in a year? There are 4 quarters. So in 3 years, how many quarters will those be? It will be 3 multiplied by 4, giving us 12 quarters or 12 periods. Let us look at the rates. The rates we are given is 18% per year. 18% per year. 18% per year. What will be the rates per quarter? What will be the rates per quarter? In a year we have 4 quarters, and this is the rates for the entire year. So for us to get the rates per quarter, we divide by 4. And for us to convert to a decimal, we divide by 100. And this will give us 0.045. This will give us 0.045. Let me write it up here. We are saying these rates will be equal to 18 divided by 4 divided by 100, and it gives us 0.045. Those will be the rates. Can we look at one last example? One last example. See, we have 6% per year over 3 years, over 3 years, paid biannually. Biannually. Paid biannually. How do we calculate that? We need to understand the meaning of biannually. Bi means we have 2. So in a year, they are going to make 2 payments. In a year, they are going to make 2 payments. So how many periods will we have? How many periods will we have? That will be determined by the number of years and the information we have here. We have 3 years, and in a year, they are going to make 2 payments. So this will give us 6 periods. That will give us 6 periods. And what are the rates per period? Rates per period. Remember, our rates are 6% per year. And in a year, they are making 2 payments. So for every period, or for every payment, the rates will be 6 divided by 2. And we need to convert the same into decimals. This will be divided by 100, giving us 0.03. This is rounded off to 2 decimal places. It has been rounded off to 2 decimal places. And lastly, we can go ahead and look at how do we calculate the periods and the rates for 4.5% per year over a period of 2 years, which is paid fortnightly. Which is paid fortnightly. As we have done in other examples, the periods N will be determined by the number of years, and the fortnights that we have in a year. Remember, fortnight means 2 weeks. And if we divide a year by 2, a year has 52 weeks, then we are going to have 26 fortnights. 26 fortnights, and this will give us 52 periods. That will give us 52 periods. And lastly, the rates. The rates we are given here, they are 4.5. We have the rates of 4.5, and remember we have 26 fortnights. So when we divide this, we will get, when we divide by 26, we will get the rates per fortnight. And lastly, to convert that to a decimal, we divide by 100, and this will give us 0.003. This is rounded off to 3 decimal places. Those will be the rates. Those will be the rates. I hope you have understood the concept of compound interest using the simple interest formula. We mold that simple interest formula to help us to solve questions in compound interest. It is something unique and very interesting. I hope you have enjoyed, and you also know how to calculate the number of periods and the rates, because this information will come in handy when we'll be looking at the compound interest formula and its applications. So in our next lesson, we will be looking at how to apply the compound interest formula in totality to solve questions related to compound interest instead of using the simple interest formula. That will be the second method of calculating compound interest. It is a good lesson, an interesting one that you can't afford to miss. Welcome and thank you.